This is my fully wireless audio mixer. It controls my master volume, Spotify and Discord independently and even switches output devices with a single click. No cables, no lag and completely custom built. Let me show you how I made it. If you've been in the DIY tech space, you've probably heard of Deej. Huge shout out to Omri Herald, the creator of that open source project. It's brilliant and it's inspired me to start this journey. But Deej had two deal breakers for me. First, it's wired. I wanted a clean wireless desk setup. Second, changing which app controls which slider was a hassle. You usually have to edit config files. I wanted a dedicated control panel on my PC to swap apps on the fly. Also, I wanted to switch my audio output device from headphones to speakers with a single button press. So while inspired by Deej, I decided to build something completely different from the ground up. This isn't just hardware, the magic happens in the software. I built a custom Python control panel. Unlike traditional setups, the sliders aren't hard-coded. I can type Spotify into the middle slider box and the Python script tells the ESP32 via Wi-Fi, hey, the slider is now Spotify. The ESP32 even takes the first letter of that app name and updates the OLED display instantly. So if I switch it to Chrome, the display changes from S to C. It's fully dynamic. Plus, I added a toggle for desktop notifications so I know exactly what's happening without guessing. Now let's talk about the hardware, because this is where I face the biggest challenge. At first, the volume sliders were shaking uncontrollably on the screen. I realized the ESP32's onboard 3.3 volt regulator just couldn't handle the Wi-Fi power bursts, causing the voltage to drop and the analog readings to go crazy. I didn't mess around with capacitors. I went for the nuclear option. I used an external voltage regulator to boost the battery voltage up to a clean, stable 5.2 volts and fed it directly into the ESP32's 5 volt input. This completely eliminated the noise. For power management, I'm using a TP4056 module to handle the charging. To read the battery percentage, I set up a voltage divider circuit connected to an analog pin. In the code, I calibrated the specific multiplier value to translate the raw reading into an accurate battery percentage on the OLED screen. With the electronics sorted, I packed everything into this custom 3D printed case. One of my favorite features is this button. A short press cycles through my Windows audio output device. The Python script detects the change and sends the actual name of the device, like my headphones or monitor, back to the ESP32, which scrolls it across the screen. No more digging through Windows settings. This project started as a simple idea, but turned into a deep dive into power management and software integration. It's now a permanent part of my desk setup. I've made all the code and 3D files available if you want to build one yourself. If you enjoyed this build, hit that like button and subscribe for more engineering projects, and thanks for watching.